Liftoff! You're watching Spaceflight Now, the Ares 1X test flight.
But how many more external tanks need to be delivered here?
I think Mark might know that.
Mark
Nappi here.
It just so happens we have somebody, United Space Alliance representative in our program today, and one of our loyal sponsors. Good to have you drop by the way.
Thank you.
They have, what, 5 more to deliver here?
Well, we have we have 6 tanks,
Right.
or 6 flights left.
Right.
The one tank was just delivered this week,
Right.
and was put in the test cell. And of course, we need the LON vehicle, so we have 6 more tanks coming in.
6 more tanks coming in, 6 more times in the turn basin. You know, if the acoustics and the timing are just right when a shuttle launches, as the shockwave comes across that turn basin, you know what happens?
You see little waves?
The fish jump.
The fish jump.
The mackerel will
Have you
jump
seen
out.
that?
Yes, the mackerel will jump out of the water. Now, this is after I had a very long night the night before, so I'm not sure if I really saw that. No, I really did see that, and it happens. I wish I'd had a picture.
I've seen the same thing happen in the Indian River or the Banana River, watching it from the causeway.
So this does happen.
So,
Right.
so nobody, basically the birds and the animals don't have headsets and they're not listening to the NASA TV or the countdown.
You know,
they don't know it's coming.
It's kind of like the green flash when you see the sunset, the mackerel jumping in the turn basin. So anyway.
Lightning. Let me go to lightning here. We've had we're clear of lightning now, by the way, Mark. But last night we had a little bit of a different story, or overnight at least.
You know, why'd you just say that? This is Florida. We could have lightning any darn moment, right?
I'm going to get all set while you get struck.
Anyway, so yeah, let's talk about what happened.
We did have some lightning strikes last night. Nothing hit the vehicle. However, it did get within about 0.4 nautical miles. So our retest requirements say that we should go in and look at the systems on the vehicle. And the way we do that is we bring each system up very slowly and make sure there's no anomalies as the systems are being powered up. That's almost done, and we found no problems with the vehicle. So that'll be completed as we continue through the count. We don't expect that there'll be any problems, and then we'll just we'll get ready for another launch attempt today.
Well, a couple thoughts here that we probably should tell folks about. First of all, this is nearly as tall as a Saturn V rocket, and as a result, part of what you see out there in that picture, if you look to the, go to the flagpole and go a couple clicks to the right, you'll see 3, it looks like oil rigs almost. That's the lightning protection system, which is rather sophisticated for this particular rocket. It's a little more elaborate than it is for the shuttle, right?
Right. For the shuttle, we have, since the shuttle system isn't as high as this, we have one lightning rod that's just above the fixed service
which has
platform.
served it well. Remember that amazing shot we had a couple missions ago when it hit that.
Right, and it really is. It's there to attract the lightning strike so that it doesn't hit the vehicle. Since this vehicle is so tall, these lightning towers were built around, and then there's wires that go from one tower to the next, which is called a catenary system. And then again, it serves as a lightning rod so that it takes the lightning strike and the vehicle doesn't.
You can see that on the right side of your picture. On the left of the rocket, there is one of those towers.
Interestingly, though, despite 150 plus strikes, one of them coming to 0.4, 0.3 miles away, nothing hit the catenary system or the vehicle.
That's correct.
So,
That's correct.
The lightning's just scared of the whole system. That's good. That's good. That's the way we like it. So, all right, that's one issue. The next issue was we really enjoyed the lanyard and the removal of the cover. This, which I heard was tested quite a bit, and of course in the real world, it was kind of, well, I guess
it was a little difficult to get off.
After careful engineering analysis, the determination was to pull harder. Right?
Right. We talked to the guys last night. They were pulling so hard that the rope was actually hurting their hands, so they tied the rope around a tool and then pulled on it and got it off. But yeah, you know, we tested that thing in the VAB and it came off rather easily. But you know, just the circumstances around the pad. And you know, it's worth mentioning that you know there are different ways. If you know on the vehicle that we end up flying in the future, there are better ways to take rain covers off. We have them on the shuttle, and they actually have little parachutes that open, and they come off within the first couple of minutes of flight. But that takes a lot of money to go and design and certify something like that. So this was really an attempt to do it a little less expensive and you know, serve the same purpose. And as it turned out, it worked. It just was a little difficult getting there.
Now, when you have these folks pull, I mean, it sounds a little bit like tug of war. You pull the rope really hard. You're trying to pull against the other team. You get rope burn on your hands. I mean, so this was quite a force they had to put on it.
They did have to put a lot more force on it than they did when they ran the test. They ran the test several times in the VAB and it came right off.
So how many workers does it take to pull off the Velcro
2.
top? It takes 2. We now know. Was there a recoil? We also wanted to know, was when they pull it, does it spring back?
Of course, the rocket is so tall and it's only supported by the bottom, and at that point, it's not attached to the latching system. It does move, so it did move.
I wasn't even talking
as they
about
yanked
that.
on it, they were actually.
It can move, yeah.
So they weren't worried about it tumbling over.
No.
These guys are pretty strong guys.
Well,
these bad rats, right?
The force that the vibration and the forces that you see at rollout are much greater than what we could apply there.
One
right?
would hope. The USA has been, well, and its preceding organizations, but the workers have been by and large the same. Have been processing shuttles for a long time now, almost 30 years collectively. This was the first new vehicle in a long time,
right?
And you guys were in charge of the flow, making this all work. What were the lessons learned?
That's really one of the test objectives, is to learn from the processing of this vehicle. We used a paperless system. I just sat with some of the guys this morning and asked them about the lessons learned about the paperless system, and it was just terribly more efficient than the systems that we use on shuttle. But there were still lessons learned on how we can enhance that system, and they were collecting all those lessons learned. Access to the vehicle. We figured out there's better ways to get access to the vehicle. As we got out to the launch countdown, I was mentioning to some of the guys this morning is that we're doing a lot of work on the pad late in the flow, and maybe one of the lessons learned is that we should start some of that work a little bit earlier and not let it all pile up to the end, so that it continually hits the T0 time that we set for ourselves.
Well, it's interesting, really. You're still learning about the shuttle flow 30 years later. I mean, you're refining.
Sure.
But every flow is part of the whole process of learning how to do it more efficiently.
There's constantly new technology that we can use, and we're always experimenting with that. But you're right, we're always learning.
It's interesting that expression, buying the paper, as they say. As you go along and you sign on for each step of the way. What do you do now?
It's an electronic buy. When you log on, your username is basically your stamp. And when you finish the step, you just go and you electronically hit the box, and it records that you did it, and nobody else can do it for you.
So you're tweeting as you flow, in essence.
Basically, yeah, that's right.
Tweeting.
And it's all real time, and everybody can see it wherever in the country.
Well, I mean, it's definitely something for the 21st century.
One thing I noticed is interesting is we have the Ares 1X out on the pad, but we also have the space shuttle on the other launch pad. So you've got workers processing 2 vehicles, 2 different kinds of vehicles at the same time.
One more launch pad down.
Absolutely.
I'm sorry.
But USA is processing both the shuttle and the Ares 1X concurrently. So are some of the same workers having to flip-flop back and forth between the 2?
Yeah, that was one of the beautiful things about this whole Ares 1X mission. We used shuttle workers back and forth. We didn't hire anybody extra to go do this work. And they've literally been moving back from shuttle to Ares 1X and back to shuttle and back and forth. So that's exactly what's taking place. We had about 1,000 workers to get some experience on both programs. So it was and of course that's really good for them because they get to experience the new program.
They want to have something new. I mean, everybody wants to have some new gadget or new thing. Their new gadget's a rocket that they get to work on.
Right.
I'd imagine that's pretty exciting for some of them.
It is. It's part of what's going to be happening in the future, and they get to experiment a little bit with that now.
Well, let me ask you this. I remember, seems to me this figure sticks out in my mind. Correct me if I'm wrong. In a shuttle flow, there's like 1 million steps. Is that right?
It's
like
approximately, yeah.
Right? I assume, are we talking orders of magnitude less in an Ares, or is because this is a test vehicle, it's impossible to tell?
Well, there were quite a few less. This is a single stick rocket. It doesn't have an orbiter. The orbiter is probably the most manpower intensive element on the shuttle system. And of course, this doesn't have an orbiter. We don't have a crewed cabin. Yeah. So it's a lot simpler to go ahead and process. So it does require much less paper.
All right. And no paper.
And no paper, right.
I like that. Thank you very much, Mark. Really appreciate having you on.
Mark Nappi with United Space Alliance.
Good luck.
Loyal sponsors. We appreciate your support, and good luck today, and good luck in the future in general.
Thank you.